Hey everybody, this is the Simon Says Controller Group. I'm Justin Davis,
I'm Alex Nesbitt.
and as you can tell by our group name, we made a controller that plays Simon Says, kind of like Bop It, but it's Simon Says. So the rules of the game are you run the program, and then it will tell you that you need to press a button or press the trigger or shake the controller, and then it will tell you to do Simon Says or not to do it with Simon Says. And if it says Simon Says, you have to do it within a given amount of time. If it doesn't say Simon Says, then you're not supposed to do it or touch any of the controls. You're supposed to do nothing. And if you touch anything, you lose. You win the game by completing all the levels until the game decides that it goes too fast for you to possibly play anymore.
All right. So the game functions using the 4 buttons that we have: a flex sensor and the accelerometer. These 4 sensors collect data and go into the data collection class of our Python, which funnels data into a data array where each indice of the array stores one of the different sensors' inputs. The game takes that in the run method and selects a prompt, such as Simon Says press the red button. If that is the prompt, then we will check that prompt. So it will check for the red button to see if that is pressed. If it is pressed, then it's valid. The difficulty increases and it rinses and repeats. If the input is not valid, or say you press something when it doesn't say Simon Says, then you lose the game. And that's pretty much as simple as it gets. Any other important things, I guess, would be to say that our flex sensor here is kind of bent over the back of the board to be almost a trigger on the controller. Aside from that, it's pretty straightforward in terms of wiring and buttons and accelerometer. So we can show you how it works, and then we'll get wrapped up. All right, so we'll run this from the command window here. I'm going to shake it. I got it. I'm going to press the trigger. Got it. Red button. There's a couple good ones. We'll just wait till we get a non-Simon Says to show that. Let's see, green button, yellow button. And it is pseudo-random, so it's not perfect. Oh, and there it is. I lost the game because I shook it when it didn't say to. So we can run it one more time and just show that it times out too if you don't do anything here. So Simon said to shake it. I'm not going to shake it. And I lost the game. So that works exactly how you'd expect it to. Now, we're not going to run it all the way through and win the game because I'm not fast enough reaction time to actually win the game. So we'll just let you imagine that's what's going to happen if you're actually good at it. But
And then we can show you the finished product here. Oh, let me stop screen sharing. All right, now we can show you the finished product here. If we can get a nice, good camera focus.
So we can see our buttons, the accelerometer is attached, and our trigger, all of which are wired and connected separately to another breadboard, which is where all the actual data processing happens. We have the ADC, we've got the SparkFun connector, and we also have a resistor that processes for the flex sensor. So makes it a little simpler, so you can shake the controller and have a nice range of motion here without having to worry about any of
that. And that is our demonstration of our Simon Says game controller.
So,
lessons learned and bugs. So some of the bugs that we discovered once we got the whole controller together were the fact that there was no delay in between when you would press a button and then when it would continue to prompt you. So if you pressed the blue button, for example, if it said Simon Says press the blue button, you'd press the blue button, and then if the next action would pick up that blue button was still being pressed, and so if that action was a do nothing action, like a fake one, you would just instantly lose the game. And so we had to sort out how that worked. And then we also had some issues in where we were updating our sensors. We were updating the values if they changed. But we realized later on that we could just use the raw data itself, and it would actually be far simpler in the programming. So that way we don't need to check if the button changed. It's just if the button is pressed, you know.
Yeah.
Pretty simple. Simplify the program.
Yeah, I'd say on the wiring side too, I think because we taped a lot of these wires together to make them one nice firm bundle, I definitely learned to test the hardware before, because we ended up having to untape it to test it and make sure everything was right and make sure everything was plugged in the right way. So just testing things before finalizing them for sure is important. I think that's just about it. So thanks for watching.
Thanks for watching, guys.